So let us see the concept, which is when acceleration is variable. Now what this concept says, it says that we know when acceleration is constant, we can use equations of motion, right? Which almost every one of you might be knowing, that S is equals to ut plus half at square, v square is equals to u square plus 2as, right? And v is equals to u plus at, right? These are the three equations of motion which can be easily used. But what if we do not know if the acceleration is constant or not, right? We have four variables: t, x, where t is time, x is displacement, v is the velocity, and a is the acceleration. Now we have four variables and we do not know if acceleration is constant or not. So how do we solve these questions? Now this concept has been repeatedly asked in the past year problems in AIEEE, right? So please look into the concept very carefully. If acceleration is not constant, right, or probably we do not know if it is constant or not, what we do is we make use of integration and differentiation, and three basic equations are used, which is v is equals to dx by dt, right, and a is equals to dv by dt, and one more equation which is a is equals to v dv by dx, right? These are the three equations which are used, and generally in a question, three variables will be there, two variables will be there, or one of them will be asked, or something like this, right? So you have to use these equations. Let us see how. Let us see a problem which came in AIEEE 2005, right? Now what this problem said, this said that t is equals to ax square plus bx, right? This equation was given where a and b were constants, right? Now we were asked what is acceleration, calculate the value of acceleration. So what we do in this type of question was, now if you see the problem, one variable t is there and one variable x is there, only two variables are there, right? Now we have to find out the acceleration. But if we see the equations which calculate a, the equations which make use of variables for finding a, acceleration, are does not involve, these two equations does not involve x and t simultaneously, right? The only equation which uses x and t simultaneously is the first equation, right? So what we do is, let us start from the first equation, which is v is equals to dx by dt. Let us apply dx by dt in this formula. We differentiate the entire equation with respect to t. Differentiate the entire equation with respect to t, right? So what we will get? You might be knowing differentiation at this point of time easily. So this will be 1 will be equal to 2ax into dx by dt plus b into dx by dt, right? Now if we see the problem, what is dx by dt? This is v, right? Now let us replace this by v. So this will give us 1 will be equal to 2ax v plus 2v, bv, right? If we take v as common, we can very well get the value of v, which is 1 upon 2ax plus b, right? We get the value of v. But the problem was, we were asked about the acceleration. Now we get another equation, this is another equation which is in v and x, and we have to find out a using this equation. So which two variables, v and x, are used? Which equation uses these two variables? It is the third equation, which is v dv by dx, and if we calculate this value, we will get the value of acceleration easily, right? So what we do is, we have to find out the acceleration. Let us use the formula v dv by dx, which will be equal to, now let us put the value of v, which is 1 upon 2ax plus b, right? And we have to use the value of dv by dx. If we differentiate this value dv by dx, what we will get? Minus of 1 upon 2ax plus b whole square into the differentiation of the inner part, which is 2a, right? So we get minus 2a divided by of 2ax plus b whole cube. And we know that 1 upon 2a x plus b is what? It is v. So this will be minus 2a v cube, right? So this was there in the option, right? So we can very well see that, using only these three equations, and we have to see what variables are given. T and x are given. Definitely we have to use the first equation. Then we reduce it to another equation which involves v and x. Then definitely the third equation has to be used, right? So this is how we have to solve the question. Please see the concept very carefully, because there is a high probability a similar kind of problem will be coming this year also, because the same concept has been repeated for the last 3 to 4 years repeatedly, right?